Hello, everyone, and welcome to my YouTube channel and welcome to this particular stream. My name is Sayam Pathak, and I'm a CNCF ambassador working as Director of Technical Evangelism at CIVO, building the next gen cloud platform, managed Kubernetes service based on K3S. Be sure to check that out, civo.com/sign up. You get to $50 credit. And if you want to learn Kubernetes, then I also created a course, which is also on civo.com/academy, and it is completely free of cost. So make sure you check that out and take the advantage. More than 50 plus 50 plus videos over there. In this particular session, we'll be discussing about Crossplane, which is an infrastructure provisioning tool via the kind of Kubernetes API. And I'll just pull up a comment on the screen. So if this is a YouTube video that I created for the kind of CNCF minutes for Crossplane, so you can quickly get all the features of Crossplane in at a glance in around 7-8 minutes. Because today we'll be discussing heavily on the composition part and focusing on the demos of the composition, which is I believe a very interesting, a very cool feature out there in Crossplane. And I mean that's kind of a real multi-cloud stuff that you can do with Crossplane. So making the life of developers easy, providing them to write the minimum set of configurations, and behind the scenes you have your whole set of code that is doing all the magics, taking the value from that custom resource and then creating the resources in respective cloud accounts. So I think that's pretty neat, and obviously Dan will talk about more that. So Crossplane is just just like any other tooling that you install on your Kubernetes cluster. So you'll be installing it, and it'll be having its own controller and a bunch of stuff that it installs onto your Kubernetes cluster. Then you create your custom resources, just like you create a resource for a pod or a deployment. A similar type of YAML file you can create for a Crossplane resource, and you will be defining some of the spec sections. And Crossplane takes the advantage of Kubernetes scheduling, Kubernetes policies, security. So all these things you can also take the advantage within Crossplane. Because it is deployed on Kubernetes, it becomes a Kubernetes object, user defined Kubernetes object. And yep, this is kind of a gist of what it is. And today we'll be more heavily focusing on Crossplane composition. So be sure to stay till the end of the stream. It's going to be awesome. Dan has again promised me awesome demos. I mean, he hasn't, but I have taken that promise because because he is awesome. So you have already seen Dan in a couple of streams where the way he explains is pretty neat, and very very up to the point where you understand things. So I think that's pretty rad. And he himself is very good in doing stuff, but he's also good in explaining stuff. So that's even make him more awesome. So welcome Dan again to the stream, and thank you for rescheduling it, because I was not feeling well and I'm still recovering. And thank you all for kind of tuning in for the live session. Make sure to make it interactive, and we'll try to learn more and more as you are there. So a few of the people are there, and George posted a really nice comment as well that I would like to pull up on the screen. So glad that you are playing with the Crossplane. And we'll definitely do a lot today with the Crossplane composition, and hope you learn more. So Dan, welcome to the session. And yeah, before that, please make sure to subscribe to the channel, everyone, because that's what keeps me going. A very healthy growth that is going on. Please keep it going. I have one more video already in editing, so I'll be uploading it maybe tonight. And so that you can learn more and more. So these are walkthrough videos that I'm trying to do. And also please be nice to each other in the chat, to the speakers and the presenters. That would be really good, because we are all here to learn. So without wasting much of the time now, so I would introduce Dan. So Dan is from Upbound, who are the creators of Crossplane. And obviously he's involved in a number of things. I cannot name them. So Dan, welcome again to the stream. Please introduce yourself for the people who are just joining in for the first time and listening you.
Yeah, well, thanks for the introduction. I think you pretty much covered it. We did our RIS 5 stream last week, and that was very different than this topic. This is closer to my day job, you might say. And I hope I do half as good a job of explaining as you just mentioned that I could do there. But this is a more advanced part of Crossplane, right? Composition. However, I feel like we say that a lot. Um, but it's also at the same time really the core part of Crossplane, right? Being able to provision infrastructure via Kubernetes is nice, but that's really not the mission of the project. Really, that is just enabling the mission of the project, and the mission of the project is to allow any organization of any size to be able to define their own control plane APIs and present kind of their view of what a cloud provider should look like or an infrastructure platform should look like to developers. And that's something that personally for me, when I started working on Crossplane a few years ago, and when I joined Upbound, that's really what got me excited about doing it. Right, that's kind of the thing that gets me up every day, because I think that's a worthy mission, right? To be able to make it such that folks' velocity is improved, and that you can deploy infrastructure and self-service infrastructure safely and within the bounds of an organization. So that's really what excites me. So I'm always happy to chat about this topic. As you said, I do like to give demos. We'll certainly be giving some demos today. Actually, kind of a newer one that I haven't done on a stream before. So always the best for you. So we can go ahead and get into it though, if everybody's ready.
Yep, absolutely. So let's get the tires kicked in, and yeah, I have kind of introduced Crossplane. Do you want to do a one-liner or two-liner introducing Crossplane?
Yeah, absolutely. So Crossplane, at its basic level, allows you to define an infrastructure platform on top of Kubernetes. What that means is that when you go to a cloud provider like AWS or GCP, or maybe you have some on-prem kind of solution, right, that has an API for provisioning infrastructure. When you go to any of those, you're given a set of APIs to interact with, right? Maybe it's EC2 instances, maybe it's RDS instances, maybe it's Cloud SQL or GKE or something like that, right? You're given this kind of like platter of infrastructure options to be able to deploy and run your applications and store your data on and that sort of thing. What we want to do as Crossplane is make it possible for you to define your own set of APIs in as little as 5 minutes, right? And to be able to continue to grow that over time and really build out a platform that fits your organizational needs and allows you as a platform team or a group of SREs or something like that to present that platform to your internal developers at the level of abstraction that works for your organization.
Awesome. So now that now I hope like you have the basic understandings. People who are watching of what Crossplane is, so that you if even if you are joining just now, so at least you have some clue what Crossplane is. So now let's get into the main topic, like Crossplane composition. So what is Crossplane composition? What is this concept all about?
Yeah, absolutely. So, when you start off with Crossplane, right, we have a concept of providers, which is probably familiar to folks who have used something like Terraform or other infrastructure as code tools, right? It's how you kind of take the core engine, you extend it to target different external APIs. So we have these providers, and when you install a provider in a Kubernetes cluster where Crossplane is installed, it basically adds all of the APIs that match that external API. So for instance, if I install provider AWS, now I can create S3 bucket objects in my Kubernetes cluster, and that results in the creation of that S3 bucket externally. So you're basically adding new types, and those types are defined using custom resource definitions, which is really just a mechanism to extend the Kubernetes API. So now when you create your deployment for your application, you can also provision, its blob storage or its database, or even the compute that it runs on alongside it. And Siam, I know you mentioned kind of in the beginning this importance of standardizing on the Kubernetes API that we really emphasize with Crossplane. What that means is that, if you deliver your applications using Helm, if you deliver them using Customize, if you use some, internal solution, if you want to add policy using Open Policy Agent, because all of this infrastructure is also defined using the Kubernetes API, all of that tooling that you already use can be used to provision your infrastructure now. So that's kind of, the basic level of Crossplane in terms of bringing that infrastructure into your Kubernetes API. Now, composition is kind of the next level up where you can say, I want to create my own abstractions because when I install provider AWS, it gives me a lot of resources there and they have a lot of fields to configure, right? When I go into the AWS console and I look at provisioning a database, it's pretty complicated, right? You have to do a fair amount of research. You need to look into what these different fields are going to set, what it's going to cost, that sort of thing. And, beyond that, in a large organization, you're going to have to decide what is within your security parameters, what is within your budget parameters, right? What types of things can be spin up by anyone and what types of things need special permission and that sort of thing. And so, with that being the case, composition allows you via two core objects in the Crossplane ecosystem, which we'll talk about in a little bit. It allows you to basically define new types. So, kind of like how we defined new types using custom resource definitions for providers, it allows you to define a higher level type using what's called a composite resource definition, which is a Crossplane concept. And that type has an API just like a CRD does. If you've ever authored a custom resource definition or generated one, there's a section in that has an open API v3 schema where you're basically saying, I'm defining a new API structure for objects that can be created. You're doing that same thing with a composite resource definition, but you're not actually defining a controller to reconcile that. What you're going to do is you're going to author one or more compositions, which is the second object in the Crossplane vernacular that we're talking about here. And a composition says when instances of this new type that I defined with the composite resource definition get created, this is the underlying managed resources, which are all of those brought by a provider that get created in response. And this is how the fields on the abstract type map to the fields on the concrete types. And I know that's a lot of words, and a lot of words actually sound pretty similar, right? Custom resource definition, composite resource definition. There's a lot of terminology going on here, and we definitely acknowledge that. So I'd love to go ahead and get into showing some diagrams, and then also doing a demo, right? So we can see exactly how this works.
Absolutely. Please bring up your screen.
Awesome. All right. So I'm gonna go ahead and bring it up here, and the first thing I'm going to bring up is our guide or overview of composition that's in the docs, because this is a really simple diagram here, but is pretty illustrative of how this actually works. Um, Once you've created your composite resource definition and your compositions, your one or more compositions for that composite resource definition, there's kind of three different levels of infrastructure provisioning that's happening. So at the basic level, these composed managed resources, these are things in this case that would be installed by provider GCP, right? A Cloud SQL instance, a firewall rule. These are one-to-one mappings to that GCP API in this case. There's a composite resource, which is a cluster scoped type. So within a Kubernetes cluster, right, you have namespace scoping and you can have multiple namespaces, or you can have cluster scoping, and that's just a global namespace, right? There's a cluster scope type, and then there's a namespace scoped type. Now, this difference between namespace and cluster scoping is going to become really important to start to understand kind of how you're presenting this API. The basic level, right, is namespace is an isolation mechanism, albeit in a lot of cases a very weak one. But it is a isolation mechanism that allows you to create RBAC rules and define policy based on the namespace something is created in. So this would be kind of a state you could get into after you've already defined this Postgres instance API. And this would be the result of someone creating an instance of that Postgres type. What would actually happen, right? So you create a Postgres instance in your namespace, maybe as part of your application helm chart. That results in the creation of a kind of marker resource called a composite resource at the cluster scope level, which Crossplane then translates into a Cloud SQL instance and a firewall rule, because that's what you as a platform team have defined satisfies a Postgres type. And then when these are created by Crossplane, provider GCP's controller picks these up and starts reconciling them externally, right? So that it actually creates a Cloud SQL instance on GCP, etc. in the Crossplane kind of getting started guide, we kind of start out from this most abstract thing where you just go and create a Postgres instance and see this happen. And then we work backwards to see how you define this Postgres instance API. So, just to give you kind of an overview of what this looks like, this is what you would include in your Helm chart here, for instance. I want to, alongside my application deployment or pod or services, create a Postgres database. And I want to specify that its connection information gets written to this secret, which then I can then reference in my application deployment, right, and consume it in my application and connect to that database. So this is kind of the end state that you get into. I want to point out here that there's different tabs specifying different cloud providers and also just different configurations within a cloud provider. You're going to see that the Postgres instance, right, looks exactly the same across all of these. The only thing that's changing is this label selector, which is using the typical Kubernetes label selecting mechanism to be able to kind of like specify a type of underlying resource. This actually allows you to say, I want to match this to a certain composition. If you don't specify this, one will be picked at random, but this means that you could have your own kind of labeling scheme that was, environment dev or something like that. And then you could select the composition based on it. But the important thing here is that all of these cloud providers have different database services that can satisfy a Postgres instance requirement. And we can provision generically across all of these clouds without having to understand that here it's an RDS instance, here it's a Cloud SQL instance, and here it's a Azure SQL instance, or I always forget the term for them, but something like that. And it's all this generic API. So this is the end state we're driving towards here.
Awesome. So I think that's pretty interesting. What we are trying to do is we first try to write a crossplane composite file, and that is having the complete API spec of what the resource will actually be created for each of the providers. So the composite file will be having the components for each of the provider, because that is defined by the platform team. As a platform team, I know, like, in Azure there are these set of values and secrets which are required. For AWS there are these set of credentials, VPC, and all that stuff is required. So I'll make the composite file in such a way that all these resources are defined. But what Dan showed you, the resource that the actual developer that you will be creating, that is exactly the same. Only the provider and the label selector is changing. Based on that, it will map to whatever is defined in the composite file with respect to that label selector, and based on that, it will provision in the respective infrastructure. So basically, you as a developer do not you have been abstracted. You don't care about how it is getting provisioned behind the scenes. You just care about, okay, I want a Postgres instance, and this is my provider that I want in. That's it. And you don't want, because you don't care, you are not in the platform, you don't care about that. So you can directly just say, I want this is the provider, that's it. Behind the scenes, it will an end result, it will give you the instance, and you won't know how it is going behind the scenes. But it is the power of composition that has been used over here.
Absolutely. Absolutely. So with that kind of like end state that we want to reach, right, where we can create a Postgres instance or potentially all types of different APIs we want to define. This stream today, right, is really about understanding how we do that, which Siam was just getting into there, and we'll go through a number of demos here. I'm going to briefly show this example in the Crossplane documentation, but we're not going to use this as a demo because number one, it's kind of like a scope down case for a very simple kind of database translation. We're going to do a bit more of a complex one just for fun. But I do want to walk through this just for folks who want to go through the docs after this, just kind of to have a guided walkthrough of it. Right. So the end state we got to there was we were able to create a Postgres instance with the same API, and it could go to any cloud provider. So essentially what we need to do is two main things, right? We need to define what that Postgres instance generic API is, and we need to define the mappings from that generic API to the concrete APIs for each of the providers, right? So typically, and you can go in any order that you like, right? But the first thing you're going to want to do is define your composite resource definition, which defines the Postgres type. So you'll notice that this looks a lot like a custom resource definition, and even the group version kind of it is very similar, right? But this is a crossplane concept, and this actually leads to the creation of custom resource definitions in your cluster. But you can think of it as defining a cluster scope type and a namespace scope type in your cluster. So here we're saying we're going to define a, cluster scope type called an X Postgres SQL instance, and then a namespace scope type, which we call a claim. We call the cluster scope type a composite, and the namespace scope type a claim. You can think of it as a developer, you're claiming infrastructure, and the namespace scope type is going to be the Postgres instance here. And then we're going to define the schema for it. So this is a very, very minimal schema here, where we're saying there's just one field. It's actually required. It's just storage in gigabytes here, and it's type integer, right? Once again, this is the actual exact API that you'll see on a custom resource definition. You're defining the schema for a new type. When this actually gets created in your Kubernetes cluster, if you kube control applied this, it would Crossplane would see that, and it would create two different CRDs in response. One cluster scoped one called X PostgreSQL instance, and one namespace scoped one just called PostgreSQL instance. Then we need to create our various compositions. Like I said, you can have one or more compositions for any XRD. You could theoretically actually have 0, but that wouldn't be very useful, right? Here we're going to define 4 different compositions. And this is where you're going to start to see some divergence. So let's start with the AWS default VPC one, which we're basically saying here, the abstract Postgres instance type is going to map to an AWS RDS instance, which has a very extensive API. But we're presenting it with this simple API that just has a single field. And so here in our composition, we're going to do a number of things. One, we're going to put some labels on it, which allow us to match to that via our claim, which we saw earlier. We put that provider AWS on our claim, which meant this composition would be selected. We're going to specify where the connection secrets for all of the embedded resources are going to be written to, the namespace. So we're saying Crossplane system here. We're going to specify the composite resource definition that this is going to satisfy. So here we're saying X Postgres SQL instance. So we're specifying that composite resource definition we already defined. And I also want to point out here that our shorthand for composite resource definition is XRD. So it kind of maps one-to-one, right, with CRD. So when I say XRD, I'm talking about a composite resource definition. When I say CRD, I'm talking about a custom resource definition. So here we're saying it maps to this composite type. So whenever someone creates either a cluster scoped X Postgres SQL instance or a namespace scoped Postgres SQL instance, it is going to, if it matches to this composition, create an RDS instance, which will then be picked up by provider AWS. And we're specifying here some default fields here that are going to be in the RDS instance, as well as a mapping of some of the fields from the API of the generic Postgres instance type to this RDS instance. Notably here, we can talk about some of these in a bit, but this is the most notable where we're saying spec.parameters.storage.gb, which, as you'll remember, we defined right up here in our API. And we also supplied, right, when we created our Postgres instance type. We're going to take that field and we're going to map that to the underlying allocated storage field, which is the RDS instance API field that specifies its size, right? So we're saying from the abstract type to the concrete type, we're kind of performing that mapping for you. Once again, this is a very scoped down example that is just configuring one field with some defaults. As you'll see, though, if you want a developer to be able to configure some things and not others, right, you now have the ability to do that because you can say, in my composition, it's always going to be this field, or it's sometimes going to be this field, or I'm going to expose this configuration to a developer, or I'm not going to expose this to a developer. And you can really, the sky's kind of the limit in terms of what kind of configuration you can put there. And also, because we have this separate object that represents the abstract type that the developer creates, we can create policy on that, right? We can create an open policy agent policy, for instance, that says you can create a Postgres instance and will allow you to configure the storage size, but that storage size maximum is 20. Or maybe if you're in the dev team 1 namespace, that storage size maximum is 20, but in the dev team 2 namespace, that storage size maximum is 100 or something like that, right? You can really apply any sort of policy or mapping you'd like here. If we wanted to also allow for this Postgres instance to be satisfied by GCP, we could, and this is the example that we saw in the diagram earlier, we could map that same type, right, to a Cloud SQL instance, which is a GCP Postgres managed Postgres offering. And we're going to once again take that generic field, that storage GB, and we're going to map that to the concrete field on the Cloud SQL instance, right? Which differs from that of RDS instance. But from a developer perspective, it doesn't matter to them whether it's a Cloud SQL instance or an RDS instance, right? They just need to be able to provision it. I also want to point out you can do this with Azure, but you can also do much more complex things, right? So we're talking about mapping from an abstract database to a concrete database. Not that exciting, can be useful for sure. But when this gets really valuable is when you start to create higher level concepts that mask a lot of complexity that isn't needed for developers to understand, right? So in this case, in our first AWS example, we were just creating an RDS instance. You'll notice here we're not specifying the VPC. RDS, when you don't specify the VPC, just puts it in the default VPC in your account, which, by the way, you should absolutely never use for anything critical because that's typically exposed to the public internet without many restrictions. So if you wanted to actually create this, in maybe a more secure fashion, or you wanted to just set up some networking alongside your database, you can actually include an arbitrary number of resources for a single composition here. So when you create the Postgres instance in this case, and you specify, I want VPC new, which once again, I'll hop back over and we can look at the difference between this would just create an RDS instance in the default VPC. This one would create an RDS instance and quite a few other resources, as we'll see here. It's going to create a VPC, which you'll see the configuration for here. It's going to create 3 different subnets that reference that VPC, which we'll talk about in a moment. It's going to create a DB subnet group. It's going to create an internet gateway. It's going to create a route table. It's going to create a security group, and it's going to create an RDS instance. So all of these resources are going to be created in response to a developer provisioning a database, but all they're going to get back is their database connection information, and they don't need to worry about what's happening behind the scenes here. Now, there's lots of complexities around networking. I definitely want to point out. You'll notice here that we are opening our CIDR here to the whole internet. So you definitely want to take precautions. This is an example here that makes it super easy to get started for the generic case. But do want to point out that you do need to be careful, right, when provisioning things on a cloud provider. But anyway, this kind of illustrates, right, the full complexity, but also the way that you can define the level of complexity, right? So you could say on that Postgres instance type that you should be able to define your VPC CIDR block or something like that. You could say that you can select the region and you could map that region to all of these resources in here, right? You have one field on your Postgres instance that says the region, and you could map it to every resource underneath. I also want to point out that a bunch of these resources are related to each other, right? For instance, a subnet only exists within the context of a VPC on AWS. One of the things we hear folks ask a bunch in Crossplane Slack and users and customers we have at Upbound, they say, how do I dictate ordering when I'm provisioning infrastructure using Crossplane? And the very, very simple answer is you don't. That would actually be an anti-pattern in Crossplane. We don't want to be ordering things, right? We don't want to be saying imperatively how to do something. And when I say imperative, I mean do this thing, then do the next thing, then do the next thing, right? We want to have a declarative approach where we say, this is what I want the world to look like. Go make it so, right? And that's what you're doing with something like Crossplane. That's what you're doing with something like Kubernetes, right? When you create a deployment, you're not saying, okay, like open up this port and, create a container and, join these two network namespaces on my host node or something like that. You're not saying that, right? You're saying, here is a workload. I want it to be able to access this other workload. Make it so, Kubernetes. And so we want to be able to do that here. And one of the ways we do that is that resources that are related to one another can reference each other. So one of the ways we can do that is with a reference field or a selector field. So, for instance, in this subnet, it has a VPC field that you can set on a subnet. If you wanted to see that, you could actually go and look at the actual field. So let's just take a look at subnet here. Oh, I'm having a little trouble typing this morning, it looks like. Let's jump in here. If we looked at the subnet, you're going to see it has this VPC ID field. Now, that's not super useful if you want to provision a VPC and some subnets together, right? Because I don't know what the ID is going to be here because AWS decides that for me, right? And gives it back. So, what I want to be able to say is create this subnet, and whatever VPC gets created as a result of this, reference that in this subnet. I want the subnet in that VPC. So, we're going to use this match controller ref field, which basically means match the VPC that's in the same composition as me. You could see that we could also match via labels. So if you wanted to put labels on that VPC, you could say match the VPC with these labels. You could also say match this VPC by its Kubernetes object name. So when you do that, right, you're no longer saying create this VPC, then create this subnet in this VPC. It's saying create all of these resources. And one of the prerequisites for creating a subnet on AWS is having a VPC that exists for it. So naturally, right, Crossplane is going to wait for that VPC to come available, and then it's going to resolve that reference and create that subnet in that VPC, which means that you don't have to script, right, how these things get created. Crossplane is just going to take care of making sure all of the relations you represent are also represented externally in your infrastructure. So that was a sprint through composition, right? And we're still in kind of a scoped down place. I want to take it to a bit more of a complex situation. And I also want to mention the concept of packages, right? So we're defining all these different resources that allow us to provision infrastructure APIs. One of the things that we want to be able to do is allow, let's say I have a really good, a really nice infrastructure API. Let's say I designed this Postgres instance API, which I didn't. But if I did, and I was a really, really great architect, right, I could say, I want to share this abstraction and its mappings with other folks and potentially allow them to go ahead and extend it further, right? Implement their own examples of or their own mappings of a Postgres instance to concrete infrastructure. One of the things you can do in Crossplane is take all these different resources and define some dependencies. So in this case, we'd want a dependency on provider AWS, right? We'd want that to be present in the cluster to be able to reconcile these resources. And you can build a package, which is just an OCI image with some YAML in it, essentially. And you can push that to any registry. And when someone installs your package into their Crossplane cluster, suddenly all of the APIs that you define are going to be available to them, and they can start creating Postgres instances, which really gives you the ability to get started quickly without having to think about all of these different mappings that you may want to do. You could just take something off the shelf from a registry and say, I'd like to start creating Postgres instances with a good configuration. and kind of be off to the races. And then after that, go ahead and continue to build out your platform and modify it and improve it over time. And Crossplane will do things like making sure that all of your dependencies are present in the cluster as well. So anyway, that's kind of a way you can get started here. But I want to go ahead and jump into building our own. And to do that, I mentioned that I had a bit of a demo here that's a little bit newer that I think I tweeted about maybe a week or two ago, but we haven't really shown it off. So I definitely want to bring it out here. But before we get to that, I need to give a little bit of background on one of those packages, right? So we had a package there that defined Postgres instance abstraction. This reference platform is what we call them. This reference platform, which is a configuration package, allows you to provision Kubernetes clusters in a generic fashion on AWS, GKE, or Azure. Um, and so, for instance, let's see if we can find the mappings here. We have this cluster type that is the abstraction. And on AWS, that equals an EKS cluster, node root, IAM role policy, and actually a Helm release, which is going to put Prometheus into that cluster actually after it's provisioned. And then GCP is going to be a GK cluster, node pool, and a Helm release. Then we also have this network type, which is going to map to the resources listed here. And what you can actually do is take your abstractions and combine them into higher level ones, right? So if I wanted to, and I don't think we actually do this here, or we might, if I wanted to take a EKS example, right? So here we have an EKS abstraction, which it's kind of interesting, right? An EKS is already an abstraction of a Kubernetes cluster, but there's a lot of moving pieces there. So it's actually really useful to have an EKS abstraction. So here we have an EKS abstraction, and we have a composition, which is going to create all of these different types under the hood, right? And there are quite a few of them, right? EKS is fairly complex. I actually saw Nabarun, if any folks know Nabarun from Kubernetes lands. He was talking about that on Twitter today, how he was frustrated with some of the complexity of EKS, I think. But then you can take that EKS abstraction and then this services one, which is a simple abstraction over a Helm chart deployment into a remote cluster. And you can combine those into a higher level abstraction where we've created this cluster type that can be satisfied by EKS plus that services abstraction. So, right, like we're building a hierarchy of APIs here, or GKE plus those services abstractions. And we can go ahead and provision that. Now, one of the things that I wanted to do was be able to also provision virtual clusters via the same interface. So, right, this package is allowing me to create clusters on GKE and EKS. I wanted to also be able to say I want to create a V cluster, which is a project that basically allows you to create a virtual cluster in a cluster. And I should be able to have the same interface for that, right? I should be able to create a cluster abstraction that's satisfied by a virtual cluster. And I should actually be able to create that virtual cluster in an EKS cluster or a GK cluster that I provisioned using that cluster abstraction as well, right? So I could create two instances of a cluster, and one of those could be an EKS cluster, and one of those could be a virtual cluster in that EKS cluster. So let's take a look at what that looks like. Now, since that package is already defined, we don't actually have to copy over all of those manifests that it has. We can just declare a dependency on that package. So you'll see here, I'm saying I want any version of platform ref multicates, which is what we were just looking at, greater than v0.0.7. And I'm also specifying I want provider Helm because that's going to be necessary for provisioning the virtual cluster, which we're using Helm chart to provision. And so what Crossplane would do in response to a package built from this manifest would install all of the dependencies here and the transitive dependencies of that. So we're saying we want platform ref multicates. Okay, so it's going to install platform ref multicates, which itself has dependencies on AWS, GCP, and Helm. So it will make sure that those providers are installed. And another kind of useful thing is it's going to make sure there's no conflicts in the dependencies. So here, both platform ref multicates and our platform ref virtual cates depend on provider Helm. Crossplane is going to make sure the version of provider Helm that's installed is compatible with both of those constraints that we specified, which in this case, they're both saying, I want greater than or equal to 0.9. So it should be no problem. So maybe for a diagram of what we're kind of doing here is I'm going to spin up a local cluster. First, I'm going to provision an EKS cluster. Then I'm going to provision a V cluster in that EKS cluster. And then at the end, if we get to it, we'll create a UXP instance in that V cluster. UXP is Upbound's distribution of Crossplane. It's entirely conformant. What it allows you to do is also connect up to Upbound Cloud, which will give us a nice view into what's happening in the cluster because there are a lot of moving pieces. So we just have a console to be able to see that. You can absolutely do everything here specified with just Crossplane as well. All right, so if we take a look at the only resource that's actually going to be in this this configuration package is our vCluster composition, our virtual cluster. And we're specifying that it satisfies that composite cluster type. And all it does is create a Helm release in that cluster. And so without actually even defining our XRD, we're saying we're just going to use this XRD that's already defined in another package and just create another implementation of it, right? And you can imagine that this becomes really useful because you can define your platform APIs and then continue to add more implementations for them as you go. So I'm going to go ahead and push this up to our Upbound registry. Go ahead and delete this package here because we don't need it. Upbound registry is once again just an OCI image registry. You could do this with Docker Hub or your internal registry or anything like that. So I'm going to create a new one. We'll say a package and we'll call this virtual states. All right, so this is our package repository here. And actually, while this is going, I am going to go ahead and get my Kind cluster going and install UXP into it so that we can get a Kubernetes cluster with Crossplane in there to do everything. While I'm going along here, because there's going to be a few steps that are not super interesting, Siam, is there any kind of questions that come to mind or anything that you think we could provide some more clarity on here?
I think maybe on the side of like you already have defined three providers now. How can like if we have a crossplane provider for Civo, so if I want to add that, I mean use the repository or fork the repository and then try to add my piece over there, so where and all I have to change?
Yeah. So are you saying if you want to define your own provider or you just wanted to add like a dependency on provider
Yeah,
SIVO?
add a dependency because provider is already there. Like provider is somebody has already created for crossplane,
Hmm.
but now I want to add the dependency, and if I give provider Civo, then it should create a cluster Civo. So all those definitions where all I have to change.
Yeah, for sure. So all you would have to do here is add a provider dependency on the SIVO provider, and Crossplane would automatically install that within a valid version for you. And then you could just define another composition that mapped to whatever SIVO cluster type or set of resources you needed to create as a result of that. And then when you actually installed this one package, as we'll see here in a minute, it's going to take care of installing all of those other types, and they'll all be kind of just resolved automatically by Crossplane's package manager.
Okay, cool.
Cool. And then I'm going to use the up CLI, which just gives us a handy tool for installing packages or installing UXP/Crossplane in this case. And then also building our packages. You can also build using the Crossplane Cube Control plugin. Commands are going to look very, very similar. So basically what I want to do is bundle up this configuration package, which just includes this one composition, and push it up to Upbound Cloud. So I'm going to run up X package build. X package is kind of our shorthand for a Crossplane package. And we'll see here that I now have this .x package file. This is actually just an OCI image on disk here. And we can actually push this up to Upbound Cloud. I'm going to look at the settings here. Looks like we have to wait to make it public. But you'll see here we have a push command. I've already logged in. So I can just say, let's see, let's push. Actually, we're going to use the Upbound CLI here to push. So I'm going to say up X package push. And this repository, we named it registry.upbound.io/hashdan virtual Kates, and we'll do 0.0.1, let's say. All right, and after that pushes, it is going to be present here in our repository, and you'll see it's accepted, which basically is just ensuring that this is a valid Crossplane package. I'm going to go ahead and make this public, which means that anyone who's following along at home, you can also use this package if you like. And let's see if our cluster is all set up. It looks good. As you'll see here, the Crossplane packages actually are just installed in Upbound system here, or the Crossplane deployments are, and then we have some additional information around that, or additional pods that are going to allow us to connect up to Upbound Cloud here. And I'm actually going to go ahead and do that. On Upbound Cloud, we refer to a Kubernetes cluster with Crossplane installed as a control plane. So you can either create a hosted control plane on Upbound Cloud, which means it will run it for you, or a self-hosted control plane, which means that you're doing like this, where it's running on your own infrastructure and you just want to connect that cluster up to Upbound Cloud. So I'm going to connect our cluster up. So I'm going to say up control plane attach, and we'll say, what should we call this? We'll call this stream. And I want this in the hashdan account. And then I'm just going to do up UXP connect, which is going to take the token given back to us by this command and pass it into our UXP installation so it can connect. All right. And so if we hop over here to our control planes, you'll see that my stream cluster is coming up, and it will connect pretty quickly because we've already provisioned this cluster. And now we have a view right into our cluster here. But obviously, we haven't installed any packages or APIs or anything like that. So we need to go ahead and get to that. So I'm going to go to the Upbound registry. Let's see. Virtual Kates is the one we just installed here. You'll see I didn't really provide any information about it, but you can see that it specifies the dependencies that I declare. And I can go ahead and run this in Upbound Cloud. I'm going to put this in the Dan org. And once again, you could do this all via kube control here. But let's see. I want to do that in the hashdan account and put it in the stream cluster. And so you could do all of this via kube control, which we actually advise because it's more declarative, but we do have this kind of quick interface for being able to do it. You'll see the UXP version that's being used, that this was installed successfully, and that these are the dependencies that are going to be resolved automatically. And so if we go over to our control plane, you can see all these dependencies starting to pop up in the cluster. And if we wanted to view them here, let me make that a little smaller. You can see that platform ref multicates, which we declared a dependency on, is present, as is AWS, GCP, and Helm, which were transitive dependencies through platform ref multicates. and it might take a few moments for this to install. Looks like they're all good to go now. They're all healthy and installed. So we can go ahead and get started. And what we've done is basically created the ability to create clusters via our cluster abstraction here. So I just did this through the UI, so we don't have to go through that. I am going to go ahead and create a secret to be able to connect to AWS, because that's what we're going to use as the underlying infrastructure here. And let me hop back over. And the first thing we're going to do is create a network on AWS. So let me pull up the examples and show you what this looks like. So this is a pretty simple type here. We defined it in platform ref multicates, and it maps to the necessary networking resources on either AWS or GCP. And we're just going to specify using AWS here. Um, and this is going to be cluster scoped. So we can go ahead and apply that. All right. So we have this network type that we created. And what's supposed to happen, right, is all of the types that we defined in our composition for that network type should be created in response to it with the configuration that we passed in. So let's look at the network type here. We have our definition, which is where we just supplied this, right? This is the schema for this resource we just created. And it should map to composition AWS because we provided provider AWS here. And it should create a VPC, internet gateway, a few subnets, and a route table and a security group, it looks like. So let's see if that's actually happening. And let's also see if I configured my credentials correctly. All right. So it looks like all these things are coming up. We have our VPC here. We have 4 subnets, security group, route table, internet gateway. So all of this infrastructure was just provisioned in response to me creating a network, right? And so that is a much higher level abstraction than all of these granular resources. So, for instance, if you want to be able to spin up networks quickly, this would be one way to do that. And they all came up pretty fast, right? Because it doesn't take AWS long to provision those. I do want to show in the UI here what this looks like. We can go into multi-cloud Kubernetes where the network type is defined here, and go into our network resources, and we'll see that's here. It's saying it's unavailable because it's waiting for those all to come ready. But you can see for this network type, all of the underlying resources and the status of them and any events that happen, right? And this will bubble up and actually change this to available here in just a moment. Basically, for the abstract type to be available, all of the underlying types have to also have come available as well. All right. So now that those are up and running, our next step is going to be to create our cluster. So this is our EKS cluster. Let me pull this up again, right? So we're creating this EKS cluster on AWS. And what does that look like? Pretty simple, right? And none of this is actually specific to AWS. This is our abstraction, right? So we're having a node count and size. Obviously, EKS doesn't use the term small to describe their cluster sizes, right? But that's a generic way that we've defined a size here that could map to EKS or GKE. So go ahead and create our cluster here. Oh, no, I'm going to start with creating our AWS cluster type. And I believe our cluster, let's see, list all of our claims here. You can see our network listed here and our cluster here. And if we look at AWS now, we should see quite a few more resources, which we do. We see all of our role policy attachments. We see our node group. We see our cluster. And it looks like our cluster is actually not happy right now. So let's actually just see what's going on there. Ah, once the Crossplane system namespace. There we go. It's actually why I believe the network was unhappy as well, is trying to publish its secrets. Crossplane system, yep, and now it came available. Um, and we can also see it shows ready now. So I'm going to hop back over, and if we went into composite Kubernetes clusters, we can now see our cluster abstraction and the types that are beneath it, which is once again our EKS cluster abstraction and then our services abstraction. And we can drill down into those further as well and see the resources that make that up, such as EKS cluster, EKS node group, IAM roles and policy attachments, etc., and events on that. And we could drill down into our EKS cluster specifically here and see that now our latest event says we are trying to create our external resource now. Um, Probably should have fired this up a little bit earlier on because it does take some time for AWS to bring these up, but we can see the infrastructure being provisioned. Um, let's actually look for our cluster. So you can see our cluster here is synced, which means that it's progressing just fine, but it's not quite ready yet. And we can see all of our other resources as well. Now, when our cluster gets provisioned, we're specifying that we want to write our connection secret to clustercon AWS, which is basically going to, in this case, write our kube config to that secret. And the way we'd actually provision our virtual cluster here is to specify the network in this case, or it's actually going to map to cluster. Um, and it's going to use a provider config ref for provider helm that references the kube config for our EKS cluster, right? So we've actually created a new deployment target, and then we're going to deploy things into that. So actually, let me bring up here in just a moment. I'll do this behind the scenes real quick. I am going to bring up my AWS console here, and we can actually take a look at our EKS cluster being provisioned. While I'm doing that, Siam, did you have any other questions, or is there anything in the chat that we could answer?
There was one in the chat earlier. Maybe we can do that. Like, I don't know. It seems Crossplane GCP provider does not have support for VM instance creation,
Mhm.
but its AWS provider has. When would Crossplane be able to support VM instance for GCP?
Yeah, absolutely. So that's a great question, and there's actually some more news coming about that. But a team on Crossplane has been working on some auto generated providers recently, and we'll have some more news and documentation coming out about this. But they allow us to get full coverage of the cloud providers. So as of today, actually, you should be able to provision VMs on GCP just using provider Jet GCP, I believe, which is the new one. If you have questions about that and want to get some access kind of ahead of time, I believe our announcement might be next week or more formal announcement. Then go ahead and join Crossplane Slack, and we'll make sure to get you started over there.
Awesome.
Cool. All right, so I'm going to pull up my AWS console here. All right, so this is our EKS cluster that got provisioned, and you'll see it's still in the process. It does take some time for this to come up. But once it comes up, we're actually going to see our node group get provisioned as well, and Prometheus installed into it, all from just creating this single cluster type here, where we specified Prometheus version, but didn't have to worry about actually doing the Helm install ourselves or anything like that. I would like to get this virtual cluster spun up here, but we'll need to wait for ECAS to come available, or we can try another option since we're actually running in a Kubernetes cluster locally, right, is to do a virtual cluster in the same cluster that we're in. So I'll show that while this is coming up. Here we're going to create a provider config here that specifies that we want to use injected identity. So provider helm is running locally. Go ahead and look at that. We'll see here Crossplane provider helm. And this is what would reconcile helm objects that we create, just like AWS is reconciling all of these resources up here that we created. So while we're waiting for that EKS cluster to come up, we can actually, and I'll use the diagram for this, we can actually just put a virtual cluster in this cluster if we wanted to. So let's go ahead and do that. We are going to have to run these commands here to get our to add some additional permissions to provider helm, because by default it cannot create things in the local cluster. So we'll give it access to be able to do that. And then I'm going to go ahead and create this provider config. A provider config, you can have many of them for a single provider, but it's basically just a pointer to some credentials. So when we say injected identity in this case, that means use the service count for this pod. Earlier, you saw me create a AWS provider config and a secret with some static credentials in it, which is what we're using to communicate with AWS here. On any resource you create, you can reference a provider config and say, basically, use these credentials to provision this resource, which once again, with composition as a platform team, the developer doesn't need to specify the credentials to use, right? They say, I want a cluster, and behind the scenes in your composition, you can map that to any provider config that you like. All right. Yeah, we'll use this one. Might need to tweak some things here because this was set up for EKS. But I'm going to go ahead and create this PC in cluster here. So examples, PC in cluster, and that should be good. And then let's go ahead and try our virtual in cluster here, where we're going to use Helm in cluster, which let me just make sure that maps correctly. Yep, looks good. Virtual in cluster. And once again, we created a cluster type. So this was just like that EKS cluster that we created, right? So if we wanted to look at our claims here, we should have our AWS cluster and our virtual cluster now. And let's see. Here is our Helm object that was created in response, right? Our V cluster type right here. And so this should have been provisioned in the cluster that Crossplane's running in. So we should see our claim also come available here. Yep. So our virtual cluster is here. And if we looked at, well, let's first look at the namespaces. We now have our vCluster1 namespace. And if we want to get our pods, we'd also see the vCluster pods running here. And let me see if I have the CLI command that they use. Yeah, so we could use this to go ahead and do this. We'll start port forwarding here. Oh, wait, let's see. I need to use. I think this at a virtual cluster expert, but I've got the 0 on it there. There we go. So now if we wanted to access this cluster locally, I think this has written a kube config here. So let's try get pods, specify kube config equals kube config.yaml. And there are no pods. And you'll see if we list them all, right, we're actually accessing this cluster that's within our cluster here. So let's see what the progress of our EKS cluster is. See if maybe that's come up in time. Looks like it's still creating here. Sure does take it a while. So
Yeah,
am I
once I'll do the SIVO integration, then it won't take more than 2 minutes.
right? Exactly. That's what we need to do on the next one. Also,
Yeah.
I know we are over time here, so if you need to hop off, then totally fine to come back and finish this at a future date.
Yeah, so there's one question like, what are the skills required to contribute to Crossplane?
Yeah, so there's really no set of single skills that you need, right? All skills are welcome. Everything from writing documentation to writing tutorials to actually getting in the code base. The general structure of our kind of project, which I'll go ahead and let me grab a link here, is we have core crossplane, which is kind of like the engine for all of this. And then we have all of our different providers. And the ones in the crossplane org are kind of the larger, most used providers right now. And so each of these you can go and contribute resources to. Or in Crossplane Contrib, we have a lot more flexibility where you can go in here and there are lots and lots of different providers in Crossplane Contrib. And there's provider Sivo, for example. Um, and you can contribute to any of those, start your own. If there's one that you don't see there, then you can certainly spin up a new one and we'll get you all set up to do that as well. So, long story short, any skills are welcome. And if you come in Slack, we'll definitely help you get started.
Yep, I think that's a great point. Like, all skills are welcome because there are different levels of contributions that are there. So I think you can just get set, because like most people ask me this question, like, they are inspired by Kubernetes, but the Kubernetes code base is daunting. What are some of the other projects? So that is why I'm doing all these streams, right? So
Mhm.
these all are in the cloud native ecosystem. So it's not only the Kubernetes projects that you have to contribute to. There are other amazing projects, like Crossplane is there. It's you can start contributing to. So they are obviously not as huge as Kubernetes, but they have their own place, and they're well matured and well adopted by the community, well loved by the community. So I think you can definitely contribute to Crossplane, and eventually become a maintainer as well in future.
Absolutely, absolutely. We are always looking for new folks to get involved. And if you do get involved, there's definitely a path to become a maintainer. We've actually had some new folks become maintainers recently, which is really awesome for sure.
Awesome. So I hope that answers your question, Aditya. So I believe, like, wherever you are in college or graduate, you can just start.
Absolutely. Well, this EKS cluster is sure taking its time here. Um, but something we could do if you wanted is we could go ahead and post this on Twitter if it comes up later. Or I'm happy to stay around. I actually don't have another meeting for a few minutes.
Yeah, we can
So
stay.
it's
I
up to you.
can stay as well. No issues in that.
Awesome. Cool. Well, let's just
So
keep looking into this.
maybe what are some of the other resources from where people can get a hold of writing the composition?
Yeah, absolutely. So definitely the crossplane docs that we were looking at earlier, and there's two specific sections: composite resources being one, which kind of gives you a high level overview of the structure with some nice diagrams and that sort of thing. And then if you want to get deeper into it, if you go to the composition reference, it's going to tell you a very detailed view of all of the different fields you configure. Um, and something that's especially interesting here is when you get down to compositions, talking about how you can patch from the composite resource to the composition, because we have a lot of different transformations like map transforms or um, merging of maps or slices, connection details, readiness checks, all that sort of things. This goes through all of the different patch types. You can combine different fields together. and concatenate them and that sort of thing, make them required or optional. So there is a ton of information here as well. And as I mentioned before, Crossplane Slack is also very active. We have a lot of maintainers as well as community members that love to answer questions, love to have conversations about new features and that sort of thing. If you do have new features that you want, or you run into a bug or something like that, definitely feel free to always open issues on the appropriate repos. So if it's something with composition or the package manager, that would go on core Crossplane, for instance. If it's something more scoped to a single provider, then usually opening issues on that specific provider repo are going to yield the best results as well.
And what is that Slack link? Can you quickly point that?
Yeah, absolutely. It is crossplane.slack.io.
Okay.
And I believe for all of our, let's see, all of our information here in the README is really helpful. So we have Slack, we have a mailing list, we have Twitter, we have email if you'd like to use that. Um, and then we also have our meeting links, which is this is something I didn't touch on yet. Every 2 weeks, we have a community meeting, which has time for everything from progress towards the next release, open questions, community events. Like for instance, the stream will be linked in the next meeting event, meeting doc there. And if you write a guide or a tutorial on your personal blog, we'll bring it up there. So the meeting is a great time to kind of introduce yourself and meet folks who are working on the project, or other users, and that sort of thing.
Yeah, awesome. That is, I think, amazing, resource. So please make sure you bookmark that. The Crossplane GitHub README is the place where you'll find all the ways to connect with the team and understand how they're working, what all things they're working on, and stuff like that. So I think that would be pretty interesting. And yes, make sure to get involved now, because I mean, the project already is being used by a lot, but I mean, you can contribute more in the right direction. Which link is not working? Let me just check.
Let's
Slack.
see. Let me make sure that that's the one. Oh, it's slack.crossplane.io.
Yeah,
Sorry about
I
that.
mentioned. It's okay. I have posted that again. Slack.crossplane.io.
Awesome. Alrighty. It looks like our cluster is finally coming up here. So we can see kind of like the initial um, pods that are going to be running in it. And then also our node group, which was part of our composition for the cluster, is also coming up. Let's go ahead and list those AWS resources again. Let's see. Looking at our cluster is ready. Our node group is still coming available, but it's progressing just fine. Once again, if you want to view this in the UI, you could hop over and go to your EKS cluster, and it's going to show all the different types here. EKS cluster now available, EKS node group in process of coming available. Yeah, it had some issues because the cluster wasn't ready yet, but now that it's up, it looks like those are coming up, and they are all ready now as well. And we should see here that Prometheus is also going to pop up here in the workloads once the cluster is fully available. And I'm going to see if we have our, let's see. I'm going to see if we can already connect to this cluster. We might not be able to because, yeah, our ClusterCon AWS might not be populated. Let's just actually check that. Yeah, ClusterCon virtual. Yeah, so we'll need to wait for those to fully come up. But when they do, oh, we already have our provider config actually, so that should work for us. Yep, and you can see all our workloads coming up, and actually Prometheus also installed into our cluster here. A lot of folks actually use this to be able to just kind of have default cluster recipes, such as ones with Prometheus installed, or maybe Linkerd or your service mesh of choice, or something like that. Something that always goes in a cluster. We have folks actually create clusters with Crossplane already installed in it, right? We call this model of kind of having like a central control plane and then remote control planes, a control plane of control planes approach. And we see a lot of organizations going that route. And let's actually see, since that's installed, I'm guessing that we could go ahead and get this here. See if we can connect. So now I'm going to look at our EKS cluster that we just created. If we can connect to that. Yep. So we can actually see into, excuse me, all of the resources on our EKS cluster. So we have our local control plane, and we also have our remote control plane. And now, last thing we're going to do is create a virtual control plane in our remote control plane. So this is kind of the last step here, right, of um, putting the virtual cluster in our EKS cluster. Right? And that should come up pretty fast as long as we don't have any issues. Because it's just a Helm chart, right? So it comes up a lot faster than an EKS cluster because we're just running some pods there. And let's see if it gets installed here. Yep, so we'll see here our dev cluster 1, which is our virtual cluster. Looks like it's still coming up, but there we go. It's all ready to go. So once again, to recap, right now I'm listing claims in our local kind cluster. We also created all using the same resource type, right? We created a virtual cluster in our kind cluster. We created a remote EKS cluster. And now we've created a virtual cluster in that remote EKS cluster. So we've got lots of clusters here. And let's go ahead and actually do that port forwarding for the virtual cluster and the EKS cluster now. Let's see, I think that was dev cluster 1, and the name of that. Refresh this and see if we can see the pods in there. I believe I'm just getting the name of the virtual cluster here. Oh, that is running quite slow. There we go. Dev cluster 1, this is what I want, I believe. Said I'm not an expert on vCluster, so there's probably some folks in the chat who can do this better than I can. Let's see here. It's in vCluster 1. Right, so now I'm port forwarding this virtual cluster. There we go. In the remote cluster, and reception. I like that. All right. And it looks like we have access to our virtual cluster in our remote cluster. And if we wanted to, this is something else we've shown before. We could actually install UXP or Crossplane into that remote cluster, a remote virtual cluster. That'll take a minute for it to come up. But if we now look in our virtual cluster, you'll see this is Crossplane UXP running in a virtual cluster in a remote EKS cluster, and all of this deployed right from a single control plane cluster. And actually, if we wanted to, we could connect this virtual cluster up to Upbound Cloud as well. So let's see these coming up here. Looks like they're running. So I am going to, I'll just do it this way. Let's say kubeconfig equals that. Um, and I'm going to do up, pass it directly to. So let's say up control plane attach remote virtual, and I'm going to put that in hash dan, and let's say up UXP connect. And I'm going to specify kubeconfig we want to use is kubeconfig.yaml. I'm at my limit on self-hosted control planes, but we could go ahead and connect up our other cluster. Actually, let's do this. I'm going to detach my existing cluster. Let's see, up control plane, delete. So this is going to keep running locally, but I'm going to remove it from Upbound Cloud. And then, yeah, so it is gone now. Pop over here, should be empty. Now let's see if we can go ahead and connect that up. If you have an organizational account or something like that, you can do this just fine. All right, so we should have this control plane now connecting up to Upbound Cloud. All right, and Upbound agent is now running. And there we see remote virtual. So that is a UXP instance installed into the vCluster 1 virtual cluster in our remote cluster in EKS, all provisioned from our central control plane and connected back.
Awesome. So I think we learned a lot about the cross-plane composition, and that was the agenda actually, to go deep dive and see the actual kind of use cases. First from the documentation, Dan explained the example of Postgres very clearly, step by step, and then kind of one of the use cases how it can be used with the Kubernetes example. So you have different providers. You have you have a provider for Helm. So all these things is there. And by the way, if you don't know vCluster, I did a stream with Lucas, who is the co-founder of at Loft Labs. So there is a stream completely dedicated to vCluster. You can see. I mean, they are really good. They launched a newer platform, a newer version of their platform, Loft.sh. So I think you should check them out. Um, People doing really amazing stuff over there. JS Policy, another policy engine. You can find the stream of that as well on my channel. So yeah, you have to subscribe, right, to keep getting the awesome stuff, and you need to share as well so that other people can learn. So the stuff that you have seen today is something rad and is something pretty cool. And you should definitely, I would encourage like people who have joined today to blog about it, blog your experience, what you have learned, and just write how you have used different kind of use cases. And you can choose the name that Engin has given, like clusterception. You can blog your name like that. So I think that that would be amazing. So thank you, Dan, for amazing demo. And we made it work in the end. Everything worked, so really happy. And thank you all for staying till the end. So that is a big thing as well. You people stayed and stuck till the end and learned something new today. Please tweet out good words to Dan about how awesome he is and how much you learned today. And yeah, also tag Crossplane. And yeah, if you want, you can tag me as well. So thank you all for tuning in today, and see you next time.
Yep.
Bye
Thanks for
all.
having me, Sam.
Thanks, Dan.